Hello and welcome to the next edition of the BobCAD-CAM webinar series. Today's topic is 3D programming, day one of a 3-day webinar series talking about 3D programming. Okay. All right, the goal of today's webinar to learn and understand when to use specific 3D toolpaths. And as you know, my name is Al DiPaolo. I'm the voice of the BobCAD-CAM or BobCAD After Dark series. You can find me on Instagram. You can also follow the hashtags, hashtag BobCAD, hashtag BobCAM. All right, what are we going to learn about today? Okay, so today we're talking about 3D programming. And this is a boot camp, and the idea is to cover a lot of the common questions and topics about what each toolpath is used for, and then what are the best scenarios or conditions in order to utilize those toolpaths. Okay, so we're going to look at different roughing routines, roughing toolpaths that we would use to remove material. We'll look at how you can target steep areas of your 3D designs. Also shallow areas, okay, so you got steep and shallow, and then also toolpaths that you can use to put detail into your parts, whether it's cleaning up and whatnot, okay? Now, as always with BobCAD, you can expect fewer steps, better cuts, and more profit. If you guys have any questions about the BobCAD software, you can always give us a call, 877-333-4903. Let them know Al said to give you a call, okay? All right. Now, while I get my screen set up here, let's just do a quick shout out. So if you're in today's webinar, the way you communicate with me is with the questions area. So you can type in any questions that you want. If I ask a question, you can answer it in the question section just to get an idea of who we have with us here today. If you can just let me know who you are, where you're from, maybe city or country, and then a little bit about, what version of BobCAD you might be running, what machines you may be running, just so I can get an idea of what's going on. A great example is Larry Johnson is with us here today. It looks like he's in Northern Illinois. He's a version 32 customer, and he's running a Haas, okay? All right, so let me see what I need to do here. Let's see who we all have with us here today. All right, we got Mike, Steve, Mark, Joe, Jim, Danny. We got a bunch of guys from all over the place. Netherlands, California, Michigan. I see a lot of Haas guys in here. Mike from Bristol, thank you so much for joining us here today. Mark Myers, Iowa, very good. We got Joe from Arlington, Texas. Again, thank each and every one of you guys for spending some time with me here. Danny, he's running ProtoTrack, JD Tool. Thank you so much. Let's see, we got John, Jeremy out of Dayton, John from Washington. Again, I really appreciate you guys spending some time with us here today, and I hope you're enjoying the webinars that we've been putting out here recently. So this is part one of a 3-part series. Today we're talking about toolpath strategies, which ones to use, when, and why. Okay, so thank you everybody for the shout out. Second thing, before we even get into any toolpath settings, oh, look at him, Bob, thank you so much. He loves them. Thank you so much, Bob. We got Mark here running a Fadal, a Haas, clausing slant bed. Very good. Analim, all kinds of stuff. Thank you so much for joining us. So to begin with, now that I have a little better idea who we have with us here today, what are your 3D programming questions? Okay. When it comes to 3D programming, what topics or what are the questions that you have or something that you've struggled with? Just go ahead and fire them away. I just want to get an idea of some of the questions you guys have when it comes to 3D programming. I assume a lot of them will be addressed in today's webinar, maybe not all of them. Now, keep in mind, today we're talking about patterns, okay? Toolpath patterns. Now, what I mean by toolpath patterns, if I come in here and I create a new job, okay, let's just go ahead and get a job going. All right, so we get a job going. When I'm talking about toolpath patterns, it's really these strategies. When we get under 3D here, and we look at all these different strategies, planar, spiral, radial. This is what I'm talking about, patterns, and we want to look at a bunch of these different patterns and kind of talk about their strengths and weaknesses and the best way to utilize them. Lawrence had some questions about smooth between each pass, minimizing acceleration and deceleration. Great question. The ability to reverse a path to improve cutter performance. What direction it's cutting in. Great question there, Michael. All right, so again, that's what we're looking at is patterns. Now, there are a ton of different patterns to go through between Express, Standard, Pro, and Multi-Axis. So I'm not going to get to all of them, but I'm going to cover some of the real key ones that you guys run into. So for some of you more advanced users, this may be review, but for some of the newer users or new to V32, again, I think this is good information to go over. Now, to begin with, I'm going to use a job template, okay? Job templates are new to the V32, and they allow you to load in your CAM tree with machining strategies already set up. Okay, so that's what I'm going to do is I'm going to run the 3D Bootcamp job template. I prepped that before the webinar, and this has a bunch of strategies in there. Now, one of the things that you'll notice when running the job template, it does pick up the stock size that I used when I saved the template, and it also, Mark says, let's build the template. I agree. I'll go into that. So it does talk about, it does load the stock size. It will also load the 0, okay? And then the other thing that it has is it has all these machining strategies already in here, okay? So again, job templates is a great way really to help me demonstrate the software, but also for you to capture, store, and reuse standard processes. Really, really speeds up your programming, okay? All right, so to begin with, let's look at, this is the mill standard, okay? So I called it standard, this is the mill standard, and I want to talk about the 3 most common strategies you'll use in any CAM system. It doesn't matter what brand it is, some of the words might be a little bit different, but these are the standard 3-axis strategies. But before I get into that, let me slow down just for a second, okay? Now, when we're looking at our part file here, we want to really quickly talk about the difference between 2D and 3D machining, okay? 2D machining, what are we talking about? Drilling, pocketing, profiling, engraving, right? Okay, so for 2D machining, what are some of the things that are different about it? Well, number one, it's going to have a single depth, right? So if I come in here and let's say I come in here and I load a 2-axis routine, right? I could pick this outside edge here. You'll notice that we have a single depth for the whole shape, right? So I could pick how deep I'm going to go, but it's only going to go to 1 depth per that feature. That's the first thing with 2D. Okay, the second thing with 2D is it's not going to account for any slope of the part. Okay, so you're going to get all straight walls. You could argue you might be able to use like taper tooling. Sure, that's true. But for the most part, with 2D machining, you're dealing with straight walls, single depth for the geometry that you selected, and we're talking about drilling, pocketing, and profiling, okay? Anytime you start to get into a taper or a slope, curve shapes, things like that, that's when we're going to get into 3D, okay? So this part here, technically the outside profile, we could use a profile feature. This floor here on the bottom of this pocket, we could do a pocketing routine there, right? But again, the goal of today's webinar is to talk about 3D toolpaths, which ones to use and why. And again, we're going to look at our standard 3D toolpaths. So the first one that's up is Zlevel Rough. Okay, so Zlevel Rough is the equivalent to a 3D pocket, right? So what this is going to do is it's going to use the model as a target. So it wants to cut to the model. And then it also uses the stock as a boundary. Okay, so if we look at this toolpath here, essentially we're doing a pocket on the inside shape, and then it's doing a pocket on the outside shape. And because it's 3D, it's going to follow the slope and curvature of the model. Okay, so that's what we're looking at. The first one is a 3D pocket. Now you'll notice, okay, if I turn the stock back on here, All right, let me ghost this out a little bit and let me unblank it. You'll notice that with the 3-axis roughing routine, the Z-level rough here, it is utilizing the stock as a boundary. Okay, so if we increase our stock size, okay, if we go to the stock wizard and we increase our stock size, let's just go 1 inch this way. Okay, so we add more stock and then we recompute, we'll see that toolpath will be guided by that stock. All right. So again, the first one that we're looking at is Z-level rough. You can look at that as a 3D pocket. It's going to remove the material between the part and the stock. Okay. If the toolpath isn't cutting all the way around the part the way that you want, what you'll do is you'll come into your stock and you'll add stock on all the different sides, okay, or the sides that you want to remove material from. So I can update my stock, I can recompute my toolpath, and now you can see how the toolpath's cutting all the way around the model, okay? All right, let me go back to the stock wizard here and let's zero these out, okay? So the first one up is Z-level rough, and again, this is like a 3D pocket. It's going to target material between the stock and the geometry you've selected. Okay, so that's the 3D pocket. The next one here, let's go ahead and blank this one out. The next one here is called Zlevel Finish. Okay, so Z-level finish, sometimes also known as a waterline toolpath. This is going to be best for steep areas of the part. Now, let me come in here and adjust the setting. We're going to go to options. Right now, I have the standard Z-level finish set to innermost only. I'm going to make its cutting extents to all. All right, and then we'll recompute this, and we'll see the toolpath is going to cut the inside shapes and the outside shapes. Okay, so again, Z-level finish is like a 3D profile. It's going to step down and follow the steep areas of the part. Now you'll notice no toolpath was generated on the flats of the part or the shoulders, right? So if we look at this pocket down here in the bottom, no toolpath there. If we notice this top surface here, no toolpath there. Okay, so Z-level finish is not going to machine any of the flat areas of the part, and really it's best for just the steep areas. Okay, as the area of the model starts to flatten out, okay, so if we look at this from a front view, this is definitely steeper, but this radius here will start to flatten out. In those shallow areas, this is where you're going to see more scallops. Okay, so Z-level rough is great for roughing out the material. Okay, Z-level finish is great for the steep areas of the part. And then the next one we're going to look at here is going to be this planer. Okay, so planer, this is like mowing your lawn. It's going to go back and forth at an angle. You know, this is great toolpath to use for coverage. This is like a catch-all here. Okay, again, kind of the scenario that you'll look at here is where the surfaces are more steep, we're going to see that there's going to be greater scallops in this area. Okay, so where the planer does a good job on the shallow areas, the Z-level finish is going to do a better job on the steep areas. Okay, so let's blank this out again. So you got Z-level rough, that's going to be what you'll use for 3D pocketing, again, to hog out the material. Z-level finish, we're going to use that for the more steep areas of the part. And then we have planer. Planer is going to be best for the more shallow areas of the part. Okay, now if we look at our Z-level finish here, if we want to control it cutting on the inside of the shapes versus the outside of the shapes, we do have some options within the toolpath itself. Okay, so this one's called cutting extents. We have all, innermost or outermost, and again, using these options here, you can control where the toolpath is generated. So if I just want it on the outside, I can say outermost. If I just want it on the inside, I can say innermost. If I don't care and it can cut both sides, then I can say both, right? Okay, so this again, Z-level rough is for roughing, Z-level finish is for more of the steep areas of the part. And then what you can do is you can utilize the options within the toolpath to control where it's going to cut, all right? Now, again, the next one here is planer. Planer, you do have some options in here as well. Something like maybe the angle in which it's cutting, so you can adjust the angle in which it's cutting. Okay, so I had it on a 45, now I set it to a 0 degree. And again, where the surface becomes more steep, this is where we're going to see more scallops there, right? Now, you do have the ability to copy these machining strategies, okay, or this operation. So I can copy this operation and I can paste it, all right? And then this gives me the ability to iterate on that toolpath. And I do think when you're learning and testing and trying, it makes sense to make some copies and then kind of make some adjustments and see the difference, right? Okay, so this one we have cutting at 0 degrees. Let me blank this one out. All right, so this one we have cutting at 0 degrees, and you can see it's moving back and forth across the model. At 0 degrees, this one's cutting along 90 degrees. Again, on the more steep areas of the part, you can clearly see more scallops, right? And on the shallow areas of the part, the toolpath is closer together, so we're going to have a much tighter toolpath there, okay? Now, Zlevel Rough, what we did is we used the stock to adjust where it was cutting, right? So if the tool's trying to cut around that, actually, let's do it on the other side here. Okay, so we're going to add the stock here. All right, if we recompute this, you can see the toolpath will then extend out to where that stock is. Zlevel Finish, again, this one we have it set to innermost only right now. So let's turn this to all. All right, and if we recompute this one, we're not going to see much of a difference. You can see the toolpath, even though we adjusted the stock, it's staying along the part model. Now, if we did want it to cut deeper, let's add more stock on the bottom. All right, so let's say 1 inch here. All right, if we recompute this, again, are we going to get an adjustment? And we're not getting an adjustment as far as where that Zlevel Finish toolpath is cutting to. Okay, what it's doing, the stock is not affecting the Zlevel Finish. The part model is affecting the Zlevel Finish and where it cuts. Now, we should be able to come in here to where it says bottom of job, and if we wanted the toolpath to extend out further, right, we could say a level in which we want it to cut to. Okay, so I'm going to say it's a 1 inch thick piece of 1 inch thick part, 1 inch thick stock. I'm going to tell it to cut a 1/2 inch deeper, and I do that by adjusting that that depth there, and now you can see how I can get this to drop all the way down around. So for the Zlevel Finish, it doesn't change where the toolpath is generated when you adjust the stock. Okay, in order to have it cut down deeper with the Zlevel Finish, we can use a bottom of job. You have a top of job and bottom of job control here, and you can use that to tell it, where you want it to start cutting and where you want it to end cutting. For instance, if I didn't want it to start at 0, I could tell it to start, a 1/2 inch deeper, and we can come in and compute that, and then you can see I can control those levels of where it's cutting. Okay. There are rest machining keeps coming up. How do you handle rest machining? Planers for shallow. What is considered shallow? Shallow would be something that isn't 90 degrees, and we'll get into that some more. Okay, so we got our Zlevel Rough. We can use our stock to control where it's going to cut. We have our Zlevel Finish. This one is being driven by the part geometry. But if you do want it to start cutting at a certain level or cut to a certain level, you can use your depth options to adjust that. Okay, let's take a look at the planer, right? So we adjusted our stock here. Let's recompute on the planer, and we noticed the same thing. The planer toolpath is being driven by the part geometry. Okay, so even if we adjust the stock, it's still not cutting deeper. Now, if we want it to cut deeper, where do we go, right? Well, we can go into that particular toolpath. A good place to start is options. Okay, so under options, we have extents, and then we have part bottom. So if we adjust our cutting extents to part bottom, and then we recompute this, then this is going to cut down to the bottom of the part. Okay, if we want it to cut even deeper, all right, that's where we can use these top and bottom of job, right? So if I wanted to cut deeper, I can say go down deeper as such and recompute, and then now we're not seeing anything different. Now, that wasn't what my expectation was. My expectation was that it would go down deeper. Let me just check my settings here. Okay, so we're telling it to go down deeper, but there's no toolpath for it to drive it any deeper down. Or maybe that's at the extent. Let's go a little bit further. Yeah, so even though I'm making that adjustment, when I tell it part bottom, it's not going down any further. Okay, does anybody know how we might be able to get it to cut down further? I'm curious. There's a couple of different ways that you can approach it. Make sure to register for day 2, where we really start talking about how to contain and control where your toolpath is cutting. Okay, so again, Zlevel Rough is driven by the stock and the part geometry. Zlevel Finish is driven by the part geometry, not the stock, but you do have the ability to tell it to cut deeper by using your top and bottom of job settings. Okay, the planer is driven by the part geometry. Okay, and if there's part geometry for the toolpath to be driven along, then it's applied to that. But again, the stock isn't controlling where it's cutting. And the depth values you could use to limit where it's cutting, but you're not going to be able to use them to extend the cut. You would have to, you'd have to add some surfaces there, right? So let's say I only wanted this to go 750 deep. I could adjust my bottom of job for my planer there, and then I can recompute, and you can see how we can get it to just cut down to that depth, okay? All right. All right, so planer is back and forth. Again, you can copy features. So once you have you can copy operations. You can copy features too, but you can copy operations and then you can iterate on them to be able to see the differences. And then you can choose which one you want to keep. And if you want to remove one, you can just hit delete and then you can remove that particular operation. Okay, so that's a little bit about Zlevel Rough, Zlevel Finish, and planer. Again, Zlevel Rough, you're going to use to rough out your material. Zlevel Finish, you're going to use for more steep areas of the part. And planer, you're going to use for more shallow areas of the part, more of a catch-all. This one's great for roughing. This one's great for steep. Okay, this one's better for shallow. All right, so those are some of the standard. These are the most common toolpaths people use every single day in machining, and it doesn't matter which CAM system that you can use. Edit the toolpath. Yes, you can edit the toolpath. All right, how to edit the toolpath. Again, if you're just joining us here, any questions you have about 3D machining, doesn't matter how simple or complex, go ahead and fire away. I'm seeing a lot of questions about rest machining. Okay, so we'll see if we can get in and cover some of that. But again, any questions that you have, day 2 is going to be next Wednesday, and that's where we're going to talk about containment, check surfaces, boundaries, and things like that. Right now, we're just talking really toolpath patterns. Okay, so we got our roughing, our finishing, and our, this is our roughing routine. Zlevel Finish is great for steep. Planer is great for shallow. You can also use planer for detail as well, again, by using a boundary. The next one that I have here is spiral and radial. Again, you'll find spiral and radial in the mill standard. Okay, you mainly use spiral and radial for round shapes. Okay, so we have this circular shape here, and we can use this spiral toolpath to spiral around, starting from the center or working its way out. Okay. Does each operation know material has already been removed? No, they do not. Again, it depends on the level of software that you have. You have Express, Standard, Pro, and Premium. In the standard toolpaths, other than the Zlevel Rough in adjusting your stock, your initial stock, it wouldn't be stock driven. As you get into the Pro toolpaths, Larry, okay, as you get into the mill professional toolpaths, you're going to notice that there are some options in here called operation stock. Okay, now it doesn't automatically calculate operation stock for you. Operation stock allows you to select an STL file or a solid model to define your in-process stock. So your question, does it know where the material is left over, or is it keeping track of the stock as you go? The answer is no, but there are options in the software to tell the software the stock condition and to use that in-process stock condition for its stock boundary, so it can target that. Okay, and we'll get into a little more rest machining. Let me get through a couple of these other topics here, guys. Okay, all right. So again, on the round shape, spiral is going to do a spiral routine. Okay, radial is similar to spiral. The difference being that it radiates in and out from the outside to the center. And again, there's different adjustments for it, but these types of tool paths are great for round shapes. Now you can use spiral and you can use radial on any set apart geometry, but you gotta, again, we're trying to think with the patterns here, where the tool path is gonna go and what shapes are best for it. So again, spiral or radial are gonna be best for round type shapes, though they could be used in other applications, okay? The scallop that you're left with on some of the parts is really desirable, and using some of those patterns really do can give you a great result. All right, the next one that I have here is another roughing routine. This one's called plunge roughing. Plunge roughing is found in the mill standard, and again, this is going to be geometry based. You can see that it's not picking up the stock there. It's being tied to where the geometry is, and what this is going to do is just kind of like drill out the part. Okay, this could be used for softer and harder materials. There's a number of different applications for this. Again, some of the benefits of the plunge roughing is all the pressure goes back up into the spindle. Okay, and this is tool dependent. You know, there's certain types of tools that are designed for plunging, and plunge roughing can be a great way to remove material very quickly. Okay, the next one I want to look at here is 3-axis wireframe. Okay, so 3-axis wireframe, this would be more of a detail type tool path. Okay, 3-axis wireframe will allow you to select geometry, surface edges, or lines and arcs, okay, and convert them into toolpath. Okay, so what I did is I just selected that line right there. I got like a smaller ball mill, and it's just following along that line there. Okay, so this one, you know, that line that I particularly selected is right on the model there. That, I guess you could use that as a 2D toolpath. You wouldn't necessarily need 3-axis wireframe for that, but if I select some edges along here, you know, and maybe some of these edges here, again, I can just convert them directly into 3D toolpath. Now I do have it, cutting down to a certain depth. And what's important to understand about 3-axis wireframe is it's not compensating for your cutter at all. All it's doing is taking your geometry and it's converting it into toolpath. Okay, so you can think of 3-axis wireframe like a manual toolpath. Okay, you do have some options in here. If you're under parameters, you can either say cut to the geometry or cut from the geometry. If I choose cut to the geometry, I can tell it how many passes I want to take and how much per pass. Okay, and these will start above the selected geometry and then cut down to the selected geometry. Okay, so if I turn my shading off here, you can see I have 3 passes from above and it's working its way down. Okay, if I come back in here and I say cut from the geometry, okay, and I recompute, now you can see it's going to start from the selected geometry and then it's going to go down. All right, so again, this is more like a detail type tool path. You might use it for trimming. I consider this more like a manual tool path. So let's say that you've drawn the tool path that you want to apply. You know, you can select it and go. And kind of an example of that, let me remove that geometry. Let me recompute here. All right, I'm just going to create a new layer. I'm going to sketch some random path. Yeah, let's go like that. Okay, so I'm creating some random path here. You know, maybe let's smooth it out a little bit. So let's do chains. Okay, so I have just my geometry here. Now what I want to do is I want to take that geometry and project it down onto that model. So we can use project curves for that. We can select this and select that. All right, so now we have this this geometry here. So I just want to get rid of the stuff on the bottom, which is this stuff here. Okay, so now I have this 3D profile, and again, I want to take that 3D profile and I want to turn it into code. So we'll select that again using 3-axis wireframe, and then now again, this is cutting from the geometry, so it's going down, but this could be venting, it could be detail, it could be a cutout, a lot of different ways that you can use 3-axis wireframe. But again, you want to consider this more of a manual toolpath, and any compensation for the cutter you're responsible for. Okay, so that's the 3-axis wireframe. Let's go ahead and blank that one out. All right, so those are the standard toolpaths that I want to take a look at. All right, again, kind of backing up here, Zlevel Rough is good for roughing the material out. Again, if you don't see the toolpath cutting around your part fully, okay, that has to do with it being stock driven, so you can adjust your stock to control where that toolpath is being generated from. Zlevel Finish, again, is going to be for more vertical shapes. Okay, it is not stock driven, but if you want to extend it down deeper or control where it starts and stops cutting, you can use the parameters option for top and bottom of job. Okay. The next one that we have here, planar. Planar is your catch-all. Again, that's not stock driven. It's geometry driven. And then again, if you want to control where it's cutting, you can use top and bottom of job, but you're going to need to add geometry to your selection if you need it to cut deeper than where that geometry actually is located. Okay. When we're dealing with round shapes, you have spiral. Again, this is best for round shapes, and then you also have radial. Okay. Again, you primarily would use those for more finishing. All right, 3D plunge roughing. Again, this is just another method to remove material. This is not stock driven, it's part geometry driven. All right, the next one we have here is 3-axis wireframe. Again, this is like a manual toolpath. You can select edges that 3D chains and convert them into toolpath. Okay, and you have two options here. You have a cut from or cut to. Cut to will rough down to the selected geometry. Cut from will start where the geometry is and rough deeper into it. So I'm going to switch this one to cut to geometry. And then instead of it being above or down into the part, we can see this is roughing from above. All right, so those are our standard 3-axis toolpaths. If there's any questions about them, go ahead and fire away. Larry says, hey, how much stock is left by roughing? How much stock is left by rough cut operation to be cut later by the operation? So Larry's talking about how much stock to leave for finish. And again, you know, it's a little tricky to get into that, you know, whether it's 20 thou, 30 thou, 15 thou, you know, 100 thou. I think that's going to be tool dependent, material dependent as well. You know, if you're cutting 4140 or, you know, 301, or if you're cutting, you know, 1018, I mean, it's going to depend. So I can't give you a catch-all answer for that, but it's possible that we could talk about that in more detail on a later date, Larry. If you want to send me an email, my email is al@bobcad.com. All right, we're about halfway through right now, and we've gotten through really all the standard 3D toolpaths. Now, there's a couple of other things that I want to talk about here as well. So we looked at some of the standard toolpaths, different scenarios, different characteristics of those toolpaths. The next thing that we want to look at here is the role selection plays. Okay, so in this case, and I see this happen often where a user will select just the surfaces that they want to machine. and then they compute their toolpath, and then they see the toolpath is cutting in areas where they don't want it to. Okay, same thing with the Zlevel Finish here. If we just select these surfaces here, the Zlevel Finish, you can see it's cutting around on both sides. Okay, the planer here, same thing. If we recompute that, you can see it's cutting around on both sides of it. Okay, so selection plays a huge role as far as where toolpath is created. The biggest mistake that I see most new users make is by selecting just what they want to cut, okay, versus selecting the entire model. And the way BobCAD's gouge protection works and the way the toolpath is created, other than Zlevel Rough, some of the toolpaths will utilize the stock size and shape as a boundary. But the majority of the toolpaths here are geometry driven. So if we just have those two surfaces selected, then it's just going to try to cut those two surfaces. If we add additional surfaces to our selection, okay, and then we recompute, we can see how now those surfaces, whatever was selected is what is considered. Okay, and the toggle between the shading, I'm just hitting S on my keyboard to turn it on or off. Okay, so yes, what you select plays a big role. And again, I recommend for all new users to select all of their geometry as a starting point. Once you gain a better confidence and understanding of how to contain the toolpath and control it, then you can be a little more selective as far as where what geometry you select. Yes, you can use a boundary mark. Day 2, we're going to get into all kinds of ways to limit and control your toolpath. Today, we're really talking about the patterns, the different strategies and the results that you get from them. All right, so now what I want to do, I want to go from standard to pro. Right? So you got Mill Standard, now you have Mill Pro. Now in Mill Pro, you have Advanced Rough, Advanced Zlevel Finish, and Advanced Planer, okay? Really, what are going to be the differences here has to do with the options in the toolpath, okay? So Advanced Rough is going to work like the Zlevel Rough does, okay? Within the Advanced Rough, if we adjust the stock size, okay, that will affect where the toolpath is being driven to. Okay, so we can see the toolpath is extending out, again, being stock driven. The biggest difference for me, beyond a variety of different cutting settings, one of the key, the starting point differences between standard and pro when you're dealing with Zlevel Rough, Zlevel Rough will, let me blank these out. Zlevel Rough will use the stock as a containment boundary. The center of the tool will go to the stock geometry, right? So this is, let's turn this up a little bit. Okay, so that's our stock geometry. When we look at this toolpath, you can see the center of the tool is going to that stock geometry, okay? You don't have the ability to get the tool to start from the outside in, okay? When you're looking at Mill Pro, let me go ahead and recalculate this. One of the things that are different right away is you can see the toolpath is extending past the stock, but also at the same time, that means it's starting off the stock, okay? One of the other things that you'll notice too is you can see I have it cutting on the outside, but I don't have it cutting on the inside, okay? Using the Advanced Rough, you have some lead options and you can tell it whether it's a center cutting tool or a non-center cutting tool. If I tell it that it's a center cutting tool, then what we're going to see is it's going to cut on the outside, but we'll also see that it comes in here and machines the inside shape. By telling it it's center cutting, I'm telling it it can plunge. Okay, so now it's able to get down inside of there. If I tell it that it's non-center cutting, okay, by unchecking this, I'm telling it it can't center cut, right? So now when I go ahead and compute this, it will only cut the areas that it can work in from the outside, okay? So that's some of the differences between the standard Zlevel Rough and the advanced Zlevel Rough. Now, there are a bunch of other options in here as well. With the advanced Zlevel Rough, you're going to have a variety of different patterns. If you guys are looking for high-speed machining and there's a bunch of different names for it. We call it adaptive roughing. You're going to find that with the advanced rough, okay? Single direction, bidirectional cutting. You know, you end up getting in here to some of these intermediate steps and step ups. You have different depth options here. You know, have it only cut to the surfaces, have it cut the min-max of the stock, or the min-max of the stock and surfaces. So these again are different ways in which you can control your tool path. So let's go ahead and I'm not going to get into controlling. That's going to be day 2, but again, what we want to look at here is the main difference that I'm focusing on right now is the way the toolpath is generated based off the stock. Zlevel Rough, the center of the tool will go to the stock. The advanced rough, you can tell it to start outside of the stock, and you can also control whether it plunges or doesn't plunge. Is non-center cutting option stock driven or geometry driven? It's stock and geometry driven. Stock driven, so it knows where to start from, Scott, and geometry driven because it needs to know whether it has to plunge in an area or not. So when you say it's non-center cutting, you know, it needs to look at the part geometry and know whether it's plunging or not. So it's actually both stock and geometry driven. Hopefully that answers that question. Okay, so that is our advanced Zlevel Rough, right? Okay, so let's look at advanced Zlevel Finish. Now, advanced Zlevel Finish, again, is going to be very similar to the standard Zlevel Finish, and Zlevel Finish is best for steep areas of the part. Okay, so anywhere where it's vertical or near vertical, it's going to do a good job with that. Okay, where it starts to shallow out, that's where you're going to see some differences, right? Okay, so we're going to get in here. You know, if I adjust my depth of cut here, and then I recompute this, all right, we're going to see that it's going to add more step downs, but still, you know, where this radius is here, we're not really getting very many additional passes. Let me make sure that I adjusted the right one here. This is 50. That's fine. Okay. So again, advanced Zlevel Finish is going to be best for more steep areas, but again, as a pro toolpath, it's going to give you more control. Okay. So this one, if we want it to cut around, we're going to say part bottom. All right, we'll go ahead and compute this one, and we'll see this will cut all the way around the part model. Okay. Again, if we get in here and we look at some of the parameters here, or let's see, what am I looking for? Pattern, parameters. Oh, it's this one doesn't have it. Okay. So again, with advanced Zlevel Finish, you can control whether it starts from the top and cuts down, or if it goes bottom up. You can tell it to cut single direction. You can tell it to cut bidirectional, and you can tell it to do a spiral. Okay. So, but again, this is going to be best for the more vertical areas of the part. All right, let's finish that. And then again, there's advanced planar. Advanced planar is going to be similar to the planar, but again, it's going to have more options. So let me talk about that real quick here. I got a couple of more toolpaths to go before we run out of time. So I just want to talk real quick about some of these different options here. Specifically, let's just look at the planar. Okay, so again, planar is best for shallow areas. You can see in the steep areas of the part that there is a greater scallop here. Okay, so you'll notice in all the pro toolpaths, they're going to have more options. And if we look at this one here, let's go under patterns, right? So you have single direction, bidirectional, uphill cutting, downhill cutting. Okay, we're going to stick with zigzag right now. Okay, let's go to the parameters here. You're going to notice that there's some additional step over options. So you have a standard step over, an adaptive step over, and a perpendicular step over. So with the standard one right now, you can see on this more vertical or steeper area of the part that we're not getting a ton of passes here. So we'd have greater scallops here. Same thing in this area here. We're going to have greater scallops there, right? So, you know, what can you do to adjust that? Well, in the Pro Toolpaths, you're going to have more options, And again, one of them is going to be this adaptive step over. And with the adaptive step over, wherever the shallower areas of the part are, or I'm sorry, the steeper areas of the part, then what it's going to do is take additional passes in order to give you a more consistent finish. Okay, so there are options within the Pro to address some of those areas where you generally get leftover material. Okay, another option that we have here is a perpendicular step over. Okay, so perpendicular, all those steep areas, I'm sorry, all the shallow areas, we're gonna, or I'm sorry, yes, all the steep areas, we're gonna see the toolpath change direction. Okay, so again, when you're getting in here and you're making adjustments, I recommend you kind of just go through one at a time and see what the settings are and just get familiar with the patterns that are being generated. So that way you can really kind of dial in what you're looking for. All right, so that's, again, Advanced Rough is going to be for roughing out the material. Advanced Zlevel Finish is going to be for the steeper areas of the part. And then Advanced Planer is going to be for the shallow areas of the part. But again, as a Pro package here, you will notice some additional options like the adaptive depth steps, which can be used to help target some of the inefficiencies of those strategies, right? So Zlevel Finish is best for more steep areas. Using some of the options within the toolpath, you can see how I can tighten up those the toolpath on the shallow areas where it's not as good. Okay. All right, so that's a little bit about that one. All right, the next one that I have here is Equidistant. Equidistant is going to be a great detailed toolpath or catch-all toolpath, right? Okay, so let's go ahead and just compute this one. What Equidistant will do, it's an offset style toolpath. And again, you're going to see it as more of like a catch-all. Now, currently I'm using some options to have it come around and break the edge of the part at the same time. Okay, but again, this is generally used more for a detail type toolpath or just a catch-all. Okay, so again, it depends on whether you're making tooling or the part themselves. But the scallops that are left based off of this pattern, you can tighten it up and it'll give you a good finish. But because you're changing direction a lot, those change of directions will show up in your parts. Okay, so Equidistant, detail, more catch-all. Okay, this next one is Project Curves. Okay, and Project Curves is similar to the 3-axis wireframe. The difference being is, again, we have more options, right? So in this case, one of the really big differences is the compensation of the cutter. Okay, so Project Curves will compensate for the cutter. Okay, and then you have options in order to tell it whether you want it to cut just to the selected geometry or whether you want it to do some offsetting, right? So if I come into this pattern here, what I can do is say user defined, and then whatever the geometry is that I've selected, then it will just convert that to toolpath. And again, if we look at this from a front view, we can see that the tool itself is being compensated for, right? So you can see how it keeps that tangency as it goes down the line, right? Where unlike the 3-axis wireframe, where all we did was convert the toolpath into G-code, or we selected geometry, but it's not compensating for the cutter at all. All the compensation in 3-axis wireframe is done by the user. In Project Curves, the software is actually looking at the part geometry and compensating for it. Okay, all right. So that is a little bit about Project Curves. And again, this one's super cool because this is great for detail work. Equidistant is great to you can define like an area you want to cut in, and it might be all curvy and stuff, and it will clean up that area. So Equidistant is a good catch-all in detail work. Project Curves is also a good detail tool as well, where you want to drive the tool along a certain angle or anything like that. You can use geometry for that. And then you can also have it offset in either direction. You can control whether it cuts in one direction or another. Some of the sorting options here. So again, if we come in here And instead of selecting, that edge, let's select this edge. You can see how we can get kind of like a blend between these two areas. Okay, and you're not limited to a single curve. I can select a couple of these here. I'm not sure what's going to happen on that intersection, so let's take a look. So you can see how you can start driving some detail work or detail coverage with project curves. Again, there's a lot of different ways that you can use project curves, but I generally think of this one more as a detail type toolpath. And there's some limitations. Here I have it offsetting either way, so that looks fine. If I select this edge on the side of the part, let's say like this one here, and we're trying to project down onto that one, we're gonna run into a limitation of how far it'll be able to drive that toolpath across a vertical wall. Okay, so if we expand this a little bit more, you can see that it doesn't really cut any further down this way because there's no geometry to drive it. You don't seem to be selecting a surface. Yeah, Mark, the reason why I'm not selecting a surface is this is my feature. I've selected the target geometry for that feature, and then I'm just working with the individual operations. I don't have to select them every time because the parent selection of the model is up here at the top. Okay, so hopefully that makes sense. All right, so again, project curves we're going to use for more detail. All right, the last one that I kind of want to get into here is going to be, let's blank this one out. Okay, the last one is flatlands. Flatlands you can use to machine all the shoulders of your part. You can just target the flat areas of your part. And, this is great. This is a great facing off bosses and different shoulders. Instead of going in and creating 2D pockets for it, what you can do is just use flatlands, and that will target all the flat areas of the part. Now, the other one that I have in here, is pencil. Pencil is used to clean up the intersection of your geometry. So what I did is on this layer here, I just have a couple of other bodies that I've added. So I'm just going to add those into our selection here so we can get some inside curves. Okay. Let's go ahead and blank this one out and compute this one. And what we're going to see with the pencil is the pencil is going to go ahead and clean up inside corners. Okay, so you can see how pencil will go in and target some of those inside corners. And again, there's some different rules as far as like the tool size and the radius that you're trying to target. But pencil is going to be used for cleaning up the inside radiuses of shapes or intersections. Okay, now again, it's really important, guys. This job tree here, I prepped these so that I could demonstrate specific topics, but you should be using the job tree templates. And really with just a little bit of work, a little bit of testing, you can set up a standard job tree template that could be applied to a whole product line or a whole process and spend less time figuring out the details of the settings for the toolpath and spend more time just selecting the geometry you want to cut. So it's a huge takeaway. I really love these templates. I use them all the time. And if you're not using them, you should be. Okay, the last 3D toolpath that I want to talk about here, this is in the multi-axis. So we covered standard toolpaths. We covered the Pro toolpaths, right? The multi-axis, this is Mill Premium. 4-axis Pro, 5-axis Pro, right? When you get into those levels. This one particularly here is morph between two curves, and this is a very popular toolpath to be used. And a good example here would be this radius here. If we want to target just this radius across the top of the model, again, there's a couple of different ways that we can approach it. This one I'm going to use one of the Mill Premium toolpaths. This is called project curve, this morph between two curves, and it allows you to select your drive surface that you want the toolpath to be driven along, and then you can select two curves that you want the morph to go between. So let's select that one. We'll come in and we're going to select this bottom one here. Again, if you guys are enjoying these webinars, please let us know. I really enjoy putting them on for you guys. If there's any particular topics that you would like to see covered in the future, definitely shoot me an email. If you have files or specific questions, those are definitely very useful. Okay, so again, this one is a mill premium type toolpath. This is morph between two curves, and you can see how we can select our drive surface and our two curves. We're getting our cut to the tangency, and it does a really good job in there. Looking for more advanced 5-axis. Absolutely, Dustin. We'll probably get into more 3+2 and some of the basic 5-axis before we get into more multi-axis package, just 4-axis or both 4 and 5-axis. This particular toolpath could be used for 3, 4, or 5. If you're a mill premium user on the tool axis control, it'll be limited to 3-axis. If you're a 4 Pro user, you'll get it for 4-axis. If you're a 5 Pro user, you'll get it for 5-axis. So 5, 4, 3 down the line. All right. And again, these are the surface-based strategies, and there's a bunch in here. These are pretty cool. Sure, you can do 3-axis plus rotary, no problem. Not a problem with that at all. All right, so let's go ahead and again, so now we kind of like we've gone through some of the toolpaths. I just have a few moments here to wrap up the topics. Again, day 2, we're going to talk about containment, how to control where the toolpath is cutting, where it's not cutting, how to trim away toolpath that might run into your fixtures. It's going to be really great. So you'll get a registration email on that here shortly. But what I want to do is I want to go back in here. Let me just blank everything out. And again, we've added some additional geometry to our model here. Okay, so if I go back into the roughing, again, because of the selection that we have, you can see that by selecting those additional bodies that now the toolpath is avoiding that. Okay, again, Zlevel Rough is great for roughing out the bulk of the material. Zlevel Finish is going to be good for the vertical or near vertical type shapes. Okay, and then planar is going to be good for the shallow type areas. Okay, when it runs into a near vertical type shape, like in this area here, you can see we're not getting the best coverage there. Okay, so again, that's why you'll use a combination of strategies in order to machine these details in there. Okay, same thing with this spiral routine here. Okay, so again, I'm just going to reselect and add in the additional body. Spiral is going to be best for round type shapes. Okay, and it will just spiral around, and you can use this spiral from the inside out or the outside in. Okay, radial is going to radiate from the inside out. And again, this can be used to put some pretty cool looking scallops on your part. And, you know, you can mainly use this for round shapes, but there are other scenarios where you might use the radial toolpath. Okay, plunge roughing, again, is a roughing routine where you're kind of like drilling the material out. And again, you can select the model, you can tell it how much it's going to step over, and then it will work its way through that, okay, plunging it out. 3-axis wireframe, again, this is more like a manual toolpath, so you can tell, you can select the 3-axis chain and drive it along that chain, okay. In the Mill Pro, again, you got your advanced rough. Similar to the Mill Standard, this is going to be your roughing routine. Advanced Zlevel Finish, this is going to be more for vertical type shapes or steep areas. Planar is going to be for more shallow type areas. Okay, Equidistant is a good catch-all. And again, just because it's a good catch-all, it doesn't necessarily mean you want to use it in all scenarios. Because the tool changes direction a lot, it can affect your finish. Again, I use this more as a catch-all or more as a detail type toolpath. And again, just kind of showing you the differences of the different toolpaths here. Again, project curves. I really like the project curves toolpaths. There's a lot of different ways in which you can use that. Again, the big difference between 3-axis wireframe and project curves is project curves will compensate for the cutter. And again, you can use, I'm picking edges off the model here, but you could create your own wireframe and use that wireframe to drive the direction of that toolpath. Okay. All right. Let's see. What else? So we have flatlands. Again, flatlands is going to machine all the flat areas of the part. So if there's any shoulders or anything like that, or any bosses, that's going to go in there and machine the flat areas of the part. And then again, pencil is going to go in and machine the inside corners. Okay. And then as you elevate, if you become a Mill Premium user, I probably could do a whole webinar just on the premium toolpaths. This is an example of a morph between two curves routine. And again, this gives you a lot of control. I would say in the multi-axis toolpaths, they're like Mill Premium. Even though there's ways that you can make them into roughing routines, it's likely that's going to be more finishing type work. Steep and shallow specific toolpaths are in there. And I think that it's really very, very useful. Thank you so much. Now, there are a couple of things here. Number one, make sure to sign up for next week's webinar where we really dive in and get into containment and how to control containment, controlling where the toolpath is cutting and not cutting. Okay, so that's number one. Number two, again, if you guys have any questions about the BobCAD software, you can expect fewer cuts or fewer steps, better cuts, more profit. But, just call us. Call us with your questions. We're here to help. 877-333-4903. Any questions that you guys have, make sure to sign up for next week's webinar where we get into containment. And I look forward to seeing you guys then. Thank you so much.